This is even and odd functions, problem type 1. And so we are asked, it's a 4-part question. We have to get all of the parts right. So 4 functions are given. They're either even, odd, or they're neither. So we get a look at them. 2 are given to us as graphs, 2 are given us as symbolic functions, and so we will take a look at both ways of looking at these. So first of all, we get even. What does the meaning of even from a graph means? It means that the y-axis will cut it in half. Okay, so we come here, go here's the y-axis. Do we get symmetry about the y-axis? So even functions will have symmetry. Maybe it's 2 m's. Symmetry. That doesn't look quite right. Throw in an extra m. Symmetry over the y-axis. And we can see, yes, on both sides it's equal. It cuts it in half. So this definitely is an even function. If it didn't have this, and we'd look at odd, and because you may get this, an odd symmetry is going to be symmetric about the origin. And so a typical one that is something like an x cubed, which would look something like this, maybe. We're going to see that would be an odd function. And I don't think we're going to get one here, but this would be an odd function. So if you rotate it 180 degrees, is the way I like to think of it. I call it spinner symmetry. If you rotate it 180 degrees, it lands on itself. Both the bottom and the top just sort of switch. You kind of have to look at that. So that's what odd function would look like. And if it doesn't do either of these, then it's neither. So let's look at this one. It certainly is not, if you were to spin this, it doesn't spin around the origin. So it's not an odd function. And then the y-axis, no, it doesn't cut it in half. It's getting cut in half over here at positive 1, not at the y-axis. So this is not an even function. It's not an odd function. This one has neither type of symmetry. Okay. Now, when they give us the function itself, we're going to do this in 2 ways, but the fast and easy way is we can look at the exponents. If all the exponents are even, then the function will be even. If all the exponents are odd, then the function will be odd. And if the exponents are a mix of even and odd, as they are in this case, right? Here's 4, which is even. Here's 3, which is odd. They are neither even nor odd. They're kind of both, right? But it gives us neither type of symmetry. Okay, these are neither, we would consider these not an even function or an odd function. It's something else. It's like this one up here, right? That's what ends up happening. Now, the nice part is when you have a function, you could actually verify this by graphing it. So we'll do, let's see if it'll do g of x. I think it will. Equals 3x squared. And what I did for the exponent is I used the shifted 6, the little caret, that little chevron above it. If you, otherwise, you could use this button here, right? So this is x, and then if you click this, this gives you the exponent key, and we do the squared. And we see, we might zoom out a little bit or zoom in. We do have this symmetry around the y-axis. Okay, so that's working. So it does validate our function here. And let's look at this other function. We'll just leave it g of x. It doesn't matter. Or you could just do y, but we could do the same thing. 5x to the 4th power. And you can shift it 6 is a faster way. Then you have to arrow to the right to get down on the line. And then we've got minus 6x to the 3rd power. And we see, no, this is not symmetric about the y-axis, right? Because it's not the same on the left and the right if we do that. And then we could just kind of, let's verify this again here. Use their line tool. Just go from here. For the y-axis, it is not symmetric on both sides. And then also, if you were to spin this thing, you could kind of see it's not going to land on itself. It'll be upside down. It's not. It doesn't have odd symmetry. It doesn't have even symmetry. It's got neither. Okay, no symmetries. So that's how we take a look at even and odd functions, either the graph or the function values.